All right. Now this one looks very similar to the last one, right? Um, we have a graph of the velocity versus time, only there's no scale. There's no scale on this graph. So we have, says the velocity of an object is described by the graph below. How far from the starting point did the object end up? And what is the total distance traveled by the object? All right. So, okay, we don't have any units, but whatever this area is, right, is the distance traveled, right? So I basically have three squares. So I have 3 units of distance, right? So I can say that we went 3 units, whatever the units are. We went 3 units in the positive direction, right? Because the velocity here is positive. The velocity is positive. So we're traveling in the positive direction. So the distance from wherever we started is increasing. Okay. Now, what does this mean? Now, you can see the axis is here. So 0 has to be here. And now these are negative velocities, right? If the velocity is negative, that means the distance from where we started is decreasing, right? So now we're traveling in the negative direction. And we've again got 3 units of area, but now it's negative. So we have -3 units of area. -3 units of area, right? That's because we're traveling in the negative direction, right? So that's what the negative indicates. It indicates that we're traveling in the negative direction. So the displacement from the starting point is decreasing. So if we went 3 units in the positive direction and then 3 units in the negative direction, what does that mean? That means we're back to where we started, right? So we can say that the object ends up, ends up back where we started, back where it started. Okay. So the displacement is 0. Let me write that down. Displacement is equal to 0, right? The displacement is 0. We're back at where we started. Now, the other question is, what's the total distance that we traveled? Okay. So we went out and back, right? We went in the positive direction. We came back in the negative direction. Now, if you were to maybe go for a run, you leave your house, you run 3 miles out and 3 miles back, right? Now you're back to where you started, so your displacement is 0, but you covered some distance, right? You covered some distance. You ran 6 miles, right? So it's the same thing here. We covered 6 units of distance, so the object traveled 6 units of distance. So we can say, let's see, but the object traveled 6 units of distance. All right, so what I'm trying to help you see is the difference between displacement and distance, right? The distance you went is 6 miles. You know, you went out 3 miles or whatever the units are, and then you came back, back to where you started. So your displacement is 0 at the end of this time period. Your displacement is 0 because you're back at the same position, but you did cover 6 units of distance or 6 miles or whatever the units are. All right. All right. So that's the key idea here is this idea of negative area, right? The area below the horizontal axis is counted as negative area, right? And it's the distance, right? It's the area from, again, between the horizontal axis and the graph of velocity. It's just that the velocity is negative, so we end up with negative area. All right, I will see you in the next video.